So today's lecture is the content of today's lecture is periodic and aperiodic signals. So before putting a statement for periodic signal, let me explain the concept to you through certain examples. So I want you to look at these figures, right? So let us look at figure number 1. So what you observe in figure number 1, that there is a square wave, and this square wave has a certain pattern which repeats, right? So this square wave is continuously repeating with a certain pattern. Similarly, when I look at figure number 2, what do I observe? In figure number 2, there is a triangular pattern here, and this triangular pattern is repeating after certain time instant. Right? I see a structure which is repeating after equal amount of time. Right? So first two examples which have been shown to you are of CT signals. Right? So these patterns are repeating after equal amount of time. That is what we understand when we look at these signals. Similarly, let us try to analyze DT signals. Right? What we observe here, this DT signal XN has certain samples. Let us say there are 4 samples which have magnitude 1 and there are 4 samples which have magnitude -1. What do you observe? That these patterns are repeating. Again, after +1, 4 samples, there are -1, 4 samples. There is again +1, 4 samples. There is a dot here which indicates that after which there are going to be 4 samples having magnitude -1 which are repeating. On same thing is seen on the other side. After +1, 4 samples, there are -1, 4 samples. Again there is +1, 4 samples. So what do you observe? That there is a certain pattern which is repeating. Let us look at the signal SN. Right? What do you observe here? Do we see any kind of repetition in the pattern? Yes, the samples are having magnitude 1, 2 and 3. Right? Again the samples have a pattern 1, 2, 3, and these 3 samples with magnitude 1, 2, 3 are seen to be repeating throughout. Right? So these 3 samples with magnitudes 1, 2 and 3 are repeating throughout the signal SN. So we see certain repetition in the signal. Right? So summarizing all these 4 examples, can we now come to what is the title of the topic, which is says it is a periodic signal. Can I now relate the title to these examples? Yes, I see that these signals are repeating and hence I call such signals to be periodic signals. So the signals which repeat with certain positive time period after fixed amount of time period, such signals are called as periodic signals. Right? So in all these 4 examples, let it be CT signal, let it be a DT signal, we see that these signals are repeating with certain time period, and all these 4 signals are falling under the category of periodic signals. Right? So if there is certain amount of repetition, let us identify after how much amount of time are these signals repeating. So if I look into the first signal, so the first signal repeats after T0 amount of time. Right? So after T0, so I identify this is the period T0 after which the signal repeats. Indirectly, identify the time period after which the signal repeats and call that signal to be the period of the signal as T0. Similarly for the second figure, right? After the time period 0 to 1, I see that the signal repeats. So this period, this positive period is called as the T0 of the signal, after which the signal starts to repeat. Right? Similarly, you can identify it for DT signals also. Right? Where do we see the periodicity? The periodicity is seen after 8 number of samples. Right? After 4 samples which are having magnitude 1 and 4 samples with magnitude -1. After these 8 samples, we see the periodicity. These 8 samples are repeating continuously. Right? So these 8 samples form the basic period of the DT signal, which is identified as N naught. Right? So for CT signal we call the period of repetition to be T naught. For DT signal we call the period of repetition to be N naught. Similarly, for this figure, after how many samples are the signal repeating? Is the signal repeating? The signal is repeating after 3 samples, and hence these 3 samples form the basic period of the signal, that is N naught. So this way, if the signals are periodic, there exists a positive time period after which the signals are repeating. Right? So for CT signal we call that period to be T naught. For DT signal we call the period to be N naught. Right? So let us now put a statement for CT signal. So what do we understand? So CT signal is 1. A signal is said to be periodic. A CT periodic signal is 1 if it repeats itself with a minimum positive interval. Right, so this definition applies for both CT as well as DT. A signal is said to be periodic if it repeats itself with a minimum positive interval. Right, so that minimum positive interval is T naught for CT signal and is N naught for DT signal. Now let us do an interesting operations on these periodic signals. If I tell you to shift this CT signal xt by a period T naught, let us try to shift this signal by a period T naught. Let us do delay or let us do advance. Either you shift the signal by to the left hand side or to the right hand side. What waveform do you get? If I shift this signal by a period T naught, what do we observe? We observe that the same structure appears, right? So after this period, this T naught, which cycle comes? It is this cycle which comes again, right? So this signal becomes very similar to the earlier signal. Similar is for this case. If I tell you to shift this particular signal by a period T naught, right? How would the new shifted signal appear if we delay it? If we shift the signal to the right hand side, right? This cycle will move and appear here. What this cycle will be replaced by? This particular cycle will be replaced by the next triangle, the next shape of the signal, right? And after which, if we now look at the signal after doing the shifting, what we observe? That this is very similar to the earlier signal. Right, so shifting the periodic signal by a period T naught results in similar signals. Same thing is true for DT signal. If we shift the signal by N naught samples, this shift is replaced by the same samples, and hence the signal after shifting appears similar to the original signal. Same is true for the signal Sn. So putting this in a mathematical form, we get a new representation for a mathematical representation for periodic signals. Right, so we understand here that if a signal is periodic, then if we shift the signal by a period T naught, so if we do a shifting operation x of t plus T naught or x of t minus T naught, right, what do we get? We get the same signal, we get the original signal. So shifting by a period T naught results in similar signal. This is very true for periodic signals. And this time period T naught, this minimum positive time interval T naught that results in repetition of the signal is said to be the fundamental period of the signal. The inverse of which we call as F naught is the fundamental frequency of the signal. Right? So T naught is called as the fundamental period. F naught is called as the fundamental frequency. Similar is also true for DT signals. Right? So if a DT signal is shifted by N naught. N naught is what? N naught is the minimum positive interval after which the samples repeat. Right, so if we do a shifting operation of x of n plus n naught, what this results into? This shifting operation results in a similar signal. The signal looks similar to its shifted version. Right, so if this is true, definitely the signal has to be periodic. Right, so n naught here is the fundamental period of the DT signal. right? So this is about the periodic signal. So every periodic signal has a certain positive interval after which we see the repetition, and this is called as the fundamental period of the signal. Now let us look at aperiodic signals. Let us analyze aperiodic signals the similar way we analyzed periodic signals. Let us understand it by looking at certain figures. So this is our standard UT signal, right? A unit step signal. So unit step signal is 0 up to 0, and it takes a value 1 and remains 1 up to infinity. So where is the repetition in this signal? Do we observe any kind of repeating pattern in this signal? No, there is no repeating pattern in this signal. Let us take one more example, a signal xt, right? Which is 0 up to -3, then it takes a magnitude of 5, remains 5 up to +3, after which the magnitude is negative and remains up to 6. After 6 the signal remains at 0. So do we observe any kind of repetition in this particular signal? No. Right? There's no repetition neither in UT, neither in XT. Let us look at few examples of DT signals. What do we observe here? In YN signal, the samples have a magnitude 1, 2, 3, 4. Then on the negative side, the samples have magnitude 1, -2. Do we observe that these samples are repeating anywhere? There is no repetition in the pattern of the given CT, in the given DT signal. There is no repetition observed. Similar is the case for signal PN, right? Do we observe any kind of repetition in the signals of PN? We don't observe any repetition of the samples, right? So in all these examples of CT and DT signal, what we observed that there is no repetition observed in the signals, right? So if there is no repetition observed, such signals fall under the category of aperiodic signals. So signal is said to be aperiodic if it does not repeat with respect to time, right? So such signals where it is observed that there is no repetition, such signals fall under the category of aperiodic signals. So if the signal is aperiodic, there is no repetition. If there is no repetition, definitely there is no probability of having a fundamental period present in the signal. So aperiodic signals do not have fundamental periods. Right? Let this be very, very clear. Fundamental period and fundamental frequency is absent for aperiodic signals, right? Fundamental period, fundamental frequency exist only for periodic signals, because there we see repetition, and the minimum amount of time after which the signal repeats, we call that minimum period to be the fundamental period. So in a periodic signal, as there is no repetition, there is absence of T naught. There is no T naught here, and hence there is no fundamental frequency present. So this is what you should understand clearly between periodic and aperiodic signals. So with this background of periodic and aperiodic signals, let us try to solve certain examples. So look at the very first example. Look at the way the statement is asked to us. The problem says find whether the following signals are periodic or aperiodic. If the signal is periodic, find the fundamental period and the fundamental frequency. Right? So we have to check whether the signal which is given to us, they fall under the category of periodic or aperiodic signals. If the signals are periodic, we have to find the fundamental period or the frequency of the signal. So let us look at the first example. The first signal is xt is equal to 2 into sine of 3t plus pi by 6. Right, so we have to analyze whether this given signal is periodic or aperiodic. Right, so we'll compare it with the standard CT signal. Right, how do we represent a standard CT signal? We represent a standard CT signal as xt is equal to a sine of omega t plus theta. This is how we write a standard CT signal, sinusoidal CT signal, right? Now let me compare the given signal xt with the standard signal. So when I compare, what do I understand? The amplitude A is 2, omega is 3, and theta is pi by 6, where theta is the phase of the signal. Omega is the frequency in radians. A indicates the amplitude, right? So if I compare, I get the signal of the calculation of interest to me is in the frequency omega. I am not interested in the phase, neither I am interested in the amplitude. We are interested because we want to calculate the fundamental period and the frequency. We are interested in the term omega. So when I compare both the given signal with the standard representation, I get the omega term. So what is omega? Omega turns out to be 3. And how do we express the radian frequency? We express it as 2 pi f. Now instead of writing f, I am writing f naught because that indicates the frequency, fundamental frequency of the signal. Right? So it is 2 pi f naught is equal to 3. So with this I get f naught to be 3 by 2 pi. Right? And this f naught is the fundamental frequency of the signal. So this way I calculate the fundamental frequency of this signal because it's a sinusoidal signal. A sinusoidal signal repeats after a fixed time interval t naught, and we know that this signal is a periodic signal, and hence we obtain the fundamental frequency f naught, which is represented by the equation 3 by t naught. Here f naught is nothing but the fundamental frequency of the given signal. Once we get f naught, now we can calculate t naught of the signal. So t naught is nothing but simply the reversal of inverse of f naught. So if we reverse f naught, we get the fundamental period of the signal. So t naught is nothing but 1 by f naught, which is 2 pi by 3. So 2 pi by 3 indicates the fundamental period. So what do we understand here? That the signal, given signal xt, is periodic and it repeats after a time period of 2 pi by 3. So t naught indicates a period of 2 pi by 3, after which the signal repeats. After every 2 pi by 3, we see a repeating pattern in the given signal xt. Now let us go for the second example. So here the second example is xt is equal to e raised to j 10t. Xt is given as e raised to j 10t, right? So how do we find the fundamental period and frequency? So we'll compare it with the standard representation of the signal. How do we write the standard representation of the signal? We write it as xt is equal to e raised to j omega t. This is how we write a standard representation of a complex signals, right? So here I compare the signal, the standard representation with the given signal. So I easily come to know that omega is having a value of 10. So with omega 10, right, I'll now calculate the fundamental period and fundamental frequency of the signal. So with omega is equal to 10, I get omega expressing as 2 pi f naught is equal to 10. F naught turns out to be 5 by pi. So the fundamental frequency of the given signal is 5 by pi. How do we calculate the fundamental period? We calculate the fundamental period by taking inverse or reversal of f naught, right? So f t naught is 1 by f naught. So I take the reversal of this. So I get 5 by pi by 5, which is nothing but 0.2 pi is the fundamental period of the signal. So this way we have found the fundamental frequency and fundamental period of the given signal. Let us look at one more example here. So here xt is given as ut minus 0.5. Right? We saw where the given signal is xt is equal to ut minus 0.5. Right? Now here xt is dependent on ut. And what about UT? How is a UT signal? We know that UT signal is a non-repeating, non-periodic signal. Right? UT itself, as we had just discussed when we discussed about non-periodic signals or aperiodic signals, that UT is not repeating. UT is 0 for t less than 0 and UT is 1 and remains 1 up to infinity from 0. So there is no repeating pattern in UT. Right? So UT itself is a periodic signal. And if I subtract zero point 0.5 from it, I don't get any kind of, the magnitude changes, but we do not observe any kind of periodicity with this mathematical operation on UT. And therefore we conclude here that as UT is a non-periodic signal, XT is also a non-periodic signal. Right? So given signal is not periodic, given signal is a periodic signal or non-periodic signal. So if it is aperiodic, there is no question of calculating the fundamental period. It does not exist. Fundamental period, fundamental frequency does not exist for non-periodic signals. Let's go for one more example. Here they have given us that xt is equal to cos square t. Right? So if xt is cos square t, how do I find whether the signal is periodic and what is the fundamental period of the signal? So now we'll apply the trigonometric functions to solve the given signal cos square t. So I'll use the identity of cos 2 theta to simplify the given signal. So we know that cos 2 theta is 2 cos square theta minus 1. Right? So I'll be using this identity. Cos 2 theta is equal to 2 cos square theta minus 1. So from this I get cos square theta to be, if I rearrange this, I get cos square theta to be cos of 2 theta plus 1 by 2. Right? From this given identity, I calculated cos square theta and expressed it in the form of cos 2 theta. So if I apply this on my given problem, right, what do I get? Here my theta is t. Right? So cos square theta can be expressed as cos of 2 theta plus 1 by 2. So applying this mathematical identity, we got the equation for xt, a new equation for xt as cos of 2t plus 1 by 2. Right? Now we have to find the fundamental period and fundamental frequency of the signal. So I'll separate out the terms here. I'll say the first term is cos of 2t by 2 and second term is 1 by 2. Let me call the first term to be x1t. Let me call the second term to be x2t. Now I'll separately analyze x1t and x2t. So I'll start with analysis of x1t. So what do I get? I get x1t to be, I'll call x1t to be cos of 2t. So x1t is cos of 2t by 2. So I'll compare it with the standard representation. So the standard representation is cos of omega t by 2. So when I compare the given signal with the standard representation, I get the value of omega. So what is omega? Omega turns out to be 2. Omega turns out to be 2. So expressing omega as 2 pi f naught, we get 2 pi f naught is equal to 2 and f naught is nothing but 1 by pi. Now if I take reversal of f naught, I get t naught and t naught turns out to be pi. Right? Now similarly we will analyze x2t. So what is x2t? x2t is 1 by 2. What is the meaning of x as 1 by 2 in a signal here? 1 by 2 indicates the DC component of the signal. What is the role of a DC component? It will simply shift the signal. It will cause shift in the signal, right? You have done clippers, clampers, you have seen. When you add a DC component in the signal, what it results into? It results into shift in the signal, right? It gives a DC shift to the signal. So this 1 by 2 is like a shift DC component. Adding a DC component causes a shift in the signal. Frequency of the DC component is 0, right? So this is it's not going to change the time period of the signal. So this x2t has no role in deciding the frequency of the signal, and hence and the frequency of the signal is decided by the component x1t. So the overall periodicity of the signal is decided by x1t. So whatever is the fundamental frequency of x1t, that is f0 and t0, are nothing but the overall overall fundamental frequency and fundamental period of the given signal, as the complete signal xt is governed only by x1t. Right, so this gives me the fundamental frequency f0 to be 1 by pi and fundamental period t0 to be pi. So this is the fundamental frequency and fundamental period of the given signal. Now we look at few more examples. Let us make the examples a bit complex. Now we'll discuss certain problems which have two fundamental periodic signals in it. Right? We will look at certain problems here which involves which is sum of or maybe product of more than two periodic signals, right? So if a signal has two periodic functions with two different fundamental periods, right? So I have taken xt as sine of 2 pi f1 and sine of 2 pi f2, these two signals, right? 2 pi f1t and 2 pi f2t, right? So what if I have these signals, then what is the overall fundamental period of the signal? Because I have two different fundamental frequencies, I have two different fundamental periods. So the question which arises is, what is the fundamental period, overall fundamental period of the given xt, whether it is governed by f1, whether it is governed by f2, or it is governed by both f1 and f2, is what we'll find out. So I'll say here my fundamental period for the first signal is t1, which is 1 by f1, t2, which is 1 by f2. So if I have two fundamental periods, what is the fundamental period of this composite signal xt? Composite signal xt means a signal having more than one frequency is said to be a composite signal. Right, so what is the overall fundamental period of this signal xt? Whether it is t1, whether it is t2, or it is dependent on both t1 and t2 is what we have to find out. So the answer lies in a statement which says that it is given by the shortest time by which these signals have an integer number. So it says that it depends on both t1 as well as t2. Right, it is given by the shortest time by which these two signals have an integer number. So both these signals are periodic. So by the shortest time by which these two signals have an integer relationship between each other decides the overall fundamental period of the signals. So to understand it, to analyze it, we will formulate certain steps. So, if such is the problem where there is involving two or more than two periodic signals, your step number one is to determine the fundamental period of the individual signal. So, in step number one, you first of all calculate T1 and T2 of the given signal. In step number two, you are expected to determine the ratio. You are expected to calculate the ratio T1 by T2. And in step number 3, we have to see how is the ratio. If the ratio is resulting into a rational number, then the given signal is periodic. If the ratio is irrational, then the signal is aperiodic. I repeat step number 3. When you get your T1 by T2 value, look at the ratio. If the ratio is rational, then the given composite signal is periodic. If your ratio is irrational, then the given signal is aperiodic. Right, now what do you mean by rational? A rational number is a ratio of two integers. Rational number is a ratio of p by q, where p is an integer, q is an integer. So a ratio of two integers is called as a rational number. Right, so if you get a form of p by q, then you call it to be a rational number, and then if it is rational, you call the given signal to be periodic. So let us better understand these, let us implement these steps in a certain numerical. So the question is, find whether the following signals are periodic or aperiodic If periodic, you are expected to find the fundamental period of the and fundamental frequency of the given signal. So the first numerical asked is xt is equal to 3 cos 3 pi t plus 7 cos of 9t. So what do I observe here? Observe here that the given signal xt is sum of two signals x1t and x2t. Right, so I have two signals here, two periodic signals. Right, so if there are two signals here, then what is the overall periodicity of xt? So for that, we'll proceed and we'll say let xt be x1t plus x2t, where we'll call x1t to be 3 cos of 3 pi t. We'll call this term to be x1t. Right, so let us analyze x1t. Let us find the fundamental period and fundamental frequency of x1t. So we'll proceed the same manner which we have done, comparing the signal with standard CT signal. So we'll compare this x1t with xt. So xt is equal to cos of omega t. So when I compare here, I am interested in getting the omega value. So what I observe is omega is 3 pi. So when I compare these two signals, I get my omega to be 3 pi. So I'll call here my omega. I'm calling here omega 1 because I have two omegas to be calculated. Right. So I'll call omega 1 to be 3 pi. Right. So with this I get 2 pi f1 which is equal to 3 pi. So f1 is the fundamental frequency of the first signal. So instead of calling f0, I am calling here, I am using f1 and f2. So I am saying f1 is the fundamental frequency of the first part of the signal x1t. So f1 comes out to be 3 by 2. If I take the reciprocal of it, I get the fundamental period t1 which is 2 by 3. So this way I have calculated the fundamental frequency and fundamental period of the first part of the signal which is x1t. I'll similarly proceed and obtain f2t and f2 and t2 for the second part of the equation. So I look at now the signal x2t. So x2t is 790. So I'll compare it with the standard signal. So cos of omega t. So I get here omega to be 9. So I say omega 2 is 9. So expressing omega 2 as 2 pi f2. Right. So I get f2 to be 9 by pi. If I solve, I get it to be 9 by pi. So from this I get t2 to be 2 pi by 9. I get T2 to be having a value 2 pi by 9. So following the steps as mentioned previously, what we did in step number 1, we were expected to calculate T1 and T2. So that's what we did. We calculated T1 and T2 of the given signals. In step number 2, we just discussed that we need to take the ratio. So in the next step, what we do is we take the ratio of T1 by T2. So when we substitute T1 and T2, these values, what we get is a value which is 3 by pi. We get the ratio to be 3 by pi. Now, to say whether the signal is periodic, what do we know? What we understand is that the ratio should be rational. Now what is happening here? Is it in a form of p by q? P is an integer, but what about q, the denominator? Q, that is the denominator, is irrational number. Pi is an irrational number. It takes a value 3.14 dot 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 dot. It is a non-terminating value. Pi is a non-terminating value. So it is not an integer. And hence T1 by T2 did not result into ratio of two integers, right? Therefore, it is not a rational number and we say ratio is irrational. So, if the ratio is irrational, what is the conclusion we make here? We make the conclusion that the given signal xt is non-periodic signal. So, given signal xt is a non-periodic signal, right? Let us understand the next example. So here xt is given to you as again a sum of two frequencies, right? involving two terms, sine of 2 pi 24 pi t into plus 7 sine of 36 pi t. So we have been given two components in the signal. So this signal xt is a composite signal. Now how do we find the fundamental period and the fundamental frequency and make the conclusion whether the signal is periodic and aperiodic? So we have to find T1 and T2 of the given signals. So for this we'll say let xt be x1t plus x2t. So x1t is the first term. So I'll say x1t is 5 sine of 24 pi t. So from this, I'll compare this given signal with the standard CT signal. So xt is equal to sine of omega t. So omega turns out to be 24 pi. So from this I understand that my first frequency omega 1 is 24 pi, expressing the frequency in hertz to be 2 pi f1 is equal to 24 pi. So f1 turns out to be 12 hertz. So f1 turns out to be 12 hertz. So we'll take the reciprocal of it and we get the fundamental period of the first signal x1t to be 1 by 12 seconds. Right? So fundamental frequency f1 of the first component x1t is 12 hertz, whereas its fundamental period is 1 by 12 seconds. Similarly, we'll proceed for x2t. So x2t is 7 sine of 36 pi t. So if I compare it with the standard signal, I get I get my omega to be 36 pi t. So I compare it with sine of omega t. So what does omega turn out to be? So omega is nothing but 36 pi. Omega is 36 pi. So expressing omega as 2 pi f2, right? What we get? We get f2 to be 18. So if we solve it, we get f2 to be 18. So f2 is nothing but, if we're taking the ratio of f2, a reciprocal of f2, we get t2 to be 1 by 18. So reciprocal of it is 1 by 18. Right? So now we have t1, we have t2. What is expected now is to take the ratio of t1 by t2. So when we take the ratio of T1 by T2, substitute T1, substitute T2, what do we get? We get the value of T1 by T2 to be 3 by 2. We get the value of T1 by T2 as 3 by 2. So look at the ratio this time. So the ratio T1 by T2 is a ratio of integer values. So both 3 and 2 are integer values. So T1 and T2 is expressed this time as a ratio of P by Q, where P and Q both are integers. Right? So this ratio is a rational ratio. So ratio is rational. And what we have just understood, if the ratio is rational, in step number 3, we have said that if the ratio is rational, then the given signal is periodic. Right? So the given signal is periodic. So T1 by T2 is periodic signal. Right? So if the signal is periodic, now we have to find the fundamental period of the signal. Right? So what is the fundamental period? Is it T1 or is it T2 or is it dependent on T1 and T2 both? So for that we will use the ratio that we have just obtained. So T1 by T2 is 3 by 2. So when I use this ratio, when I cross multiply, I get a relation 2T1 is equal to 3T2. I get a relation 2T1 is equal to 3T2. So if I now put T1, value of T1 here, what is value of T1? It's 1 by 12. So if I put here T1, which is nothing but 1 by 12, right? I get a value to be 1 by 6. Similarly, if I put T2, what is T2? T2 is 1 by 18. So if I put 1 by 18 here, right, 3 into 1 by 18 results into 1 by 6. So any value if I put here, I get the answer to be 1 by 6. So this relation gives me the overall fundamental period of the signal. This is my T naught. This is the T naught of the given signal, right? So the fundamental period of the given signal is 1 by 6. If I now take inverse of this, right? If I now take inverse of this, I get the fundamental frequency to be 6 Hertz. So here T naught is the fundamental period. This is my T naught, right? This is my fundamental period T naught of the given signal, and inverse of which is the fundamental frequency. So fundamental frequency is 6. So the given signal is periodic with fundamental period T naught to be 1 by 6 and fundamental frequency to be 6 Hertz. So this way you have to take the ratio of T1 by T2. Look at the ratio. If the ratio is rational, then you conclude that the given signal is periodic. If the signal is periodic, use the ratio T1 by T2, simplify it, and then from it you get your fundamental period T naught. Once you get your fundamental period T naught, take the inverse of it, you get the fundamental frequency. Now let us look at one more example. So your given signal xt is 5 cos of pi t into sine of 3 pi t. So it's a product of two signals. So there are two components involved here, and hence given signal xt is a composite signal. So if given signal xt is composite, I need to find t1, I need to find t2, take the ratio of t1 by t2, and looking at the ratio, conclude whether the signal is rational, irrational, and then conclude the signal is periodic or aperiodic. So let us proceed. I'll say this time, let xt be x1t into x2t. So what is my x1t? x1t is the first component, cos of pi t. Comparing it with the standard signal, I get omega to be pi. I'll call it to be omega 1. So omega 1 is pi. Expressing omega 1 as 2 pi f1, right? We get 2 pi f1 is equal to pi. So f1 turns out to be 1 by 2. Taking the reciprocal of f1, we get t1 to be 2. So what do we understand by this? That the first component, cos of pi t, has a fundamental period 1 by 2 and have a fundamental frequency 1 by 2 Hertz and fundamental period to be 2 seconds. Similarly, we'll now proceed for the second component, which is x2t. So x2t is sine of 3 pi t. So x2t is sine of 3 pi t. So I'll take omega from, I'll compare this with the standard signal. So I get omega 2 to be 3 pi. So omega 2, expressing omega 2 as 2 pi f2. So 2 pi f2 is equal to 3 pi. So f2 turns out to be 3 pi by 2 pi. So f2 is nothing but 3 by 2. So f2 is 3 by 2. Taking the reciprocal of f2, I get t2. t2 is 2 by 3. So I got t1. I've got t2. So second signal has a fundamental frequency 3 by 2 and a fundamental period of 2 by 3. So we have now t1 and t2 available. We'll follow step number 3, in which we need to calculate the ratio. So we'll now take the ratio of t1 by t2. So if we substitute t1, if we substitute t2, we get the ratio to be 3. So is the ratio rational? Yes. It is in the form of p by q, where p is 3, q is 1. Both p by q are integers. Rational number is 1, which can be expressed as the ratio of two integers. So here 3 is integer and hence the ratio is rational. So we conclude that the given signal is periodic as the ratio is rational. Now, if the signal is periodic, we need to find the fundamental period. To find the fundamental period, as I just told you, use the ratio T1 by T2. Use the ratio that you have just calculated. So, I'll use the ratio T1 by T2. So, I've just obtained T1 by T2 as 3. So, from which if I cross multiply, I get T1 to be 3i's of T2, right? So substitute T1 or substitute T2. In both the cases, you get the value to be 2 seconds, right? What is your T1? T1 is 2. What is your T2? T2 is again 2 by 3. So if I put here 2 by 3, 2 by 3 into 3 is 2. So any value if you use as per this equation, any mathematical relation if you put here, you get the answer to be 2, which is nothing but the fundamental period. This signal is your fundamental period T naught. This 2 seconds is your fundamental period T naught. Now using this fundamental period T naught, we'll calculate the fundamental frequency. So taking the ratio reciprocal of T naught, you get the fundamental frequency as 1 by 2, which is 0.5 Hertz. So the given signal is periodic with a fundamental period 2 seconds and fundamental frequency of zero point 0.5 seconds. So the signals which are involving more than two components, the procedure is to find T1, T2, right? If there is one more component, suppose T3, find T3. What you are expected to do next is take the ratio of T1 by T2. If there is one more T3 involved, take the ratio of T1 by T3. Right? So the ratios must be rational. Whatever ratio you get, the ratios must be rational. So if the ratio is rational, you say that the given signal is periodic. If the ratio is irrational, then the given signal is aperiodic. So using the ratio T1 by T2, you further calculate the fundamental period and the fundamental frequency.